Hello and welcome to the third part of workshop on tan delta testing. Today we're going to talk about UST and GST modes of measurement and what are they. These abbreviations, UST and GST, some of you might have heard about them before, but today we're going to demystify them. So to start with the process of demystification, first we're going to explain the meaning of the abbreviation. UST stands for Ungrounded Specimen Test, GST stands for Grounded Specimen Test, and GST G stands for Grounded Specimen Test GARD. GARD in this case stands for the fact that we are not measuring certain currents which come into our meter. But we will see more in details what does that mean. Also, specimen in our case means a sample, a part of our insulating system, and we can have few parts. We will see later in some examples why is this good. Generally, it's good to have as much as specimens or as much as segments as possible, because then it's easier for us to discern where, if we have a problem with insulation, and where does that problem lie. So if we take a three-phase two-winding transformer and we short circuit the primary and the secondary side, as we should when we are doing the tan delta measurement, we get an equivalent scheme of a transformer insulation like we see here. So in that case, we talk about CHL, capacitance. We can also call it parasitic capacitance, but we spoke about that before, between the high and the low voltage winding. Then CH, capacitance between the high voltage winding and the ground, and CL, capacitance between the low voltage winding and the ground. If we have in this case, for example, a three-phase transformer with three windings, primary, secondary, and tertiary, then CHL, CHT, and CLT will be measured with UST, because none of these points touch the ground, while CH, CL, and CT will be measured using a GST mode. All this talk about UST and GST might not be that important for you, but this is a video which is for those who want to know more, for people who are curious, because in today's modern equipment, basically everything is automatic, but still I think it's a good idea for people to understand what do these abbreviations mean and what actually how is actually the measurement done when we do a UST and when we do a GST mode test. So when we talk about the resolution, as we said before, it is always a good idea to test the smallest possible sample, thus having a better chance to see the influence of a small imperfection. So if we have, like here, a two-winding transformer, we will have first the capacitance between high voltage winding and the ground, then low voltage winding and the ground, and then capacitance between high voltage and low voltage winding. These capacitances present also the state of the insulation. We also have the capacitance inside the bushing, C1, and the capacitance between the bushing and the tap at the bottom of the bushing, which we call C2. So in an example number one, if we have a transformer like this and we short circuit the primary and we short circuit the secondary side, we create an equivalent scheme like we saw before. We have CH, capacitance between high voltage windings and the ground, CL, capacitance between low voltage winding and the ground, and CHL, capacitance between high voltage and low voltage. So in this case, if these are our results, 0.75, 0.56, 0.98, 0.55, and 0.62, obviously CH has the highest number. You will remember that 1% is a threshold, So if a tan delta is bigger than 1%, then we have an issue. Also, the reason why we have an issue here is not only because this number is closest to the highest and closest to number 1, but also because if we have an issue between the high voltage and the ground, this is where the tension, this is where the voltage is biggest. And that's why if we have a bad insulation here, that means in overall that we will have potentially a big issue. It is like, imagine two pipes, both of them having the same small hole somewhere in the pipe. But the first pipe has a certain pressure and the second pipe has a pressure which is 10 times bigger. If the holes are the same, obviously the second pipe will have a bigger issue than the first pipe because a bigger pressure will sooner break that little hole, or let me be more exact, the second pipe will sooner experience some kind of failure because it will take less time for a higher pressure to make that little hole into a bigger hole and completely destroy the pipe. I hope you understand the parallel I'm trying to make here. In an example number 2, we will look at a situation where, let's say, the body of the transformer is fine. All numbers are below very much 1%, but C1 is 0.95, which is very close to 1. In that case, probably very soon we will have to change our bushing, and then our transformer insulation system will be okay. Here you see some examples how to connect generation and where to connect the measurement, but we will talk about it also a little bit later. Moving on, this is an important slide where I want to explain what is actually going on when we are choosing, or when the device is choosing, UST or GST. So imagine that you have here 3 current inputs. You have current 1, current 2, and current 3. Current 1 is coming to the input B, current 2 is coming to the input A, and current 3 is coming from the ground. You can see here, this is current, this is where we measure ground current, or current running through the ground. On our test set, this is input A, this is actually input B, and this is generation. So let's say we generate 10 kilovolts here, and we have some current running through here, and some current running through here. So with a switch, we can choose whether we want to measure just this input, or only this input here, or only this input here. Or we want to measure maybe this and this, or maybe this, this, and this input, or maybe A and ground, or maybe just ground. So, long story short, if we have, let's say, an example with a transformer which has a primary, secondary, and tertiary side, then we will have one input connected to input A, another input connected to input B, and we will also have current being measured on the ground current. So once again, to make it more clear, here we have a matrix which finally explains what is a UST A. So UST A means that I'm just measuring the current coming on input A. UST B means I'm measuring only the current coming to input B. So UST A, current coming to input A, UST B, current coming to input B, and UST A plus B is the measurement of these both currents. So you can see that we are not measuring current running through the ground when we are using a UST mode, because the name says ungrounded. But then we go to a GST. GST, or grounded specimen test, means that I will measure all 3 currents, while GST GA will measure all currents but current A. So it means grounded specimen test guard A, or grounded specimen test remove A. GST GB, of course, measures everything but input B, while GST GA plus B measures only the current running in the ground. So by definition, UST will never measure the current running through the ground, and the GST will always measure a current running through the ground. And we can see here, once again, that by definition, when we define a UST, we have to say what do we measure. So here we measure input A, here we measure input B, and here we measure input A and B. While with a GST, we have to say what we do not measure. So here we measure everything. Here we do not measure input A, we do not take it into consideration, we can say. Here, in this penultimate case, we don't take into consideration current coming to input B, and here we don't take into consideration current coming to input A and B. We just measure current running through the ground. So I hope this is clear, and let us see one example. If we have a UST A, or ungrounded specimen A, as we just said, we will measure input current coming to input A. In this case, that would mean that I'm effectively measuring the capacitance CHL, capacitance between the high and the low voltage winding. So in this case, because it's a UST, both sides of the capacitors are not grounded. High voltage generation of test set is connected, as we can see here, to the high voltage part, high voltage winding of the transformer, and we are measuring current from here, and it is connected to input A. So let's see how do we do it with our test set, because we just need to say where have we connected the high voltage generation, and we connected it to high voltage winding. We also need to say what do we want to measure, and here we chose CHL, and the system automatically chose UST A. So if we want to measure CHL, when I put a high voltage generation of my device to the high voltage winding, the system will automatically choose a UST A. And this is what actually happens inside of the test set. This is the source. I am generating a high voltage here, let's say 10 kilovolts. This 10 kilovolts cause this current to run through here, and this current to run through here. Now, the fact is that we are now, since we are measuring USTA, that means that the current running in the ground will not be measured because it's a UST. We don't measure ground current when we measure a UST. So surely we will not measure CH. And then I say USTA, which means I am measuring on input A, which means that I am effectively measuring CHL. We said before what current we measure, that's the capacitance we measure. So once again, since we are only measuring current running through CHL, we are measuring capacitance between high voltage and we're measuring capacitance between high voltage winding and low voltage winding. And the current we are measuring is running through this cable and coming to input A. There is nothing connected to input B. We are not measuring anything here. We are bypassing. That means that we are bypassing the M meter, and thus we are measuring only the CHL. In our next example, we will measure CH. So in order to measure CH, obviously we need to use a GST. So we will use a GST GA, or grounded specimen test guard A. And when we do that, the connection is the same like before. In our device, we will again choose that we connected high voltage generation to the high voltage winding of the transformer. Here, we chose that we want to measure CH, and automatically our system chose GST GA mode. What effectively happens in our system is this. Once again, I'm generating high voltage to the high voltage winding of my transformer. Some current goes here and some current goes here. Now, in this case, since we are in the GST mode, by definition, we measure current running through the ground. So we surely measure the CH current. So we surely measure the capacitance CH. Then we also have this input A, this current running through CHL but connected to input A, but effectively, since I'm using GST GA, by definition, this will not be taken into consideration. So even though it seems that the current on input A is measured, because there is a cable connected to input A, internally it looks like this. I am measuring the current coming through the ground, but I'm bypassing the ammeter with the current running through the capacitance CHL. And effectively, I'm only measuring this current here, which means that I'm only measuring the capacitance of CH, or capacitor between the high voltage winding and the ground. So I hope this is clear. We have one more example. In this case, we switched the generation from a high voltage side to the low voltage side. And we are using the same method, the same mode as before, GST GA. But something will change now, because we are not anymore generating here and measuring here. Now we are generating here on the low voltage winding and measuring here and here. So on the high voltage winding and on the ground. So effectively what happens, so also you can see here that we changed the generation placement from high voltage to low voltage winding. When I'm generating on the low voltage side, I can choose to measure CL or CHL or CL plus CHL. Now I'm choosing CL, and the system tells me that the mode of measurement will be GST GA. So this is what you choose. This is also something you choose, and this is chosen automatically. And what happens inside the system? Well, I'm generating high voltage here. There is a current running through CHL, and there is a current running through CL. Since I am measuring with the GST GA mode, that means that for sure I will be measuring current running through the ground. And that also means that even though I'm connected to input A, because I have GST GA or guard A or remove A, I effectively will not be taking this current into consideration. Effectively, it will look like this. So it will look like I'm only measuring input, the ground current. So this is how the UST and GST works. You just choose which current will you measure. Will you measure only this current, or this current and this current, or maybe even a current running through here? And according to which mode you choose, that's the capacitance you measure. In this case, practically we measured CL, or the capacitance between the low voltage winding and the ground. So if we want to play a little bit, we can now say, what would I measure if I would choose the mode, if I would generate on the high voltage winding, and I would choose GST GA plus B. GST GA plus B means I'm measuring only the current through the ground. So I'm guarding A and B. I'm removing measurement coming to the input A and input B. Actually here, I didn't even draw anything connected to input A and B, because even if I did, it wouldn't be taken into consideration. But if we look here, we would see that we are measuring, if we are measuring current running through the ground, then we are measuring actually this current and this current here, which effectively gives us the capacitance, which is the parallel connection between CH and the series connection of CHL plus CL, as we can see here. So this example is not actually practical, but it gives us a theoretical, let's say, example. What would we measure if we would choose a GST GA plus B mode while the high voltage generation is placed on the high voltage winding? In case you were wondering why do we use input B, we use it for automatic measurement on a transformer that has a primary, secondary, and tertiary winding. Also, in some rare cases, input B is just another input, and if input A doesn't work properly due to a miscalibration or maybe because it's burned, we can always use this input B. So we have a transformer with primary, secondary, and tertiary side. This is the equivalent scheme. And if we place our measurements here, we will measure a certain combination of these capacitances. And more or less, with this, we are about to finish. I hope that this was clear. If not, please write your questions in the comment section. I will be more than happy to reply. And please do not forget to subscribe. Thank you for your attention. Bye.